Okay, let's start. Good morning, everybody. I wish you a very warm welcome, and I'm happy to meet you here. My name is Koen Hames. I'm the country manager of Adfinis the Netherlands. Adfinis the Netherlands is a Dutch version of Adfinis. And for all who missed it, Adfinis is the new name of Adfinis Group, the Swiss open source system integrator. A little bit of my personal background. I'm working from home at this moment. I'm father of 3 kids. I live in Hengelo, which is in the east part of the Netherlands. And I'm active with open source software as a hobby and on the professional level for more than 20 years now. Today we've got some excellent speakers for you. One is Jonathan Vermeulen. Jonathan is a senior solution engineer at the HashiCorp. And my own colleague Simon Nussbaum. Simon Nussbaum is senior system engineer at Adfinis. And in the future, we would like to present you more webinars like this for us to spread knowledge, to share experience with you, to promote the products of HashiCorp in general. Adfinis is an open source company, and that means that we want to contribute also to the HashiCorp community. And using a webinar like this is one of the methods that we can use. Enough of me. Let's go to Jonathan. And please give us a couple of seconds to switch mics. Thank you very much.
Hi, everybody. As Koen said, my name is Jonathan Vermeulen. And I'm going to tell you a little bit about HashiCorp and how we look at the cloud operating model these days. After that, Simon is going to take over and he's going to present a case that Adfinis did in recent past. So you might know HashiCorp from one of these open source products. There are quite a lot of people that actually know one of these products, but actually don't know the company HashiCorp. We are very strong in the open source community, hence why there are quite a few people that actually know the products, but didn't know that there was an actual company behind that. So we're going to change that a little bit today, and I'm going to tell you what the company stands for and what we are trying to bring to the market. So the company was founded in 2012. The first few years were just spent on this open source software, bringing this open source to the market. So there was not that much commercial activity, let's say. We were purely focused on bringing these tools to the open source community. In the meantime, we have around 900 employees now, with quite a bit of funding from some investors. And that also reflects in the customers that we have. So we have around 700 customers globally, enterprise customers, so big customers that actually, paying for our software. 7 of the 10 Fortune 10 companies, 8 of the 10 global financial companies. And most of these companies became a customer of us because they're all struggling with the same kind of migration or transition that they're going through. And that all relates to their data center and how they actually deploy and use IT these days. So most of these companies, most of your services probably as well, they traditionally resided in your own private data center, which had dedicated infrastructure. Yeah, you could look at it as a castle, maybe. It was you controlled everything. You controlled the front door. You controlled whatever happened in there. And if somebody or something was in that data center, there was a high chance that it was, that you actually intentionally put it there. So there you could trust it. But now this is changing, right? So some of these systems maybe stay in your own private data center. For most companies, we see that these are the systems of record. So maybe your databases or your data sources. And then we see that a lot of companies are actually the systems of engagement, like an app or a new website. They are going to the cloud. So you see this kind of mix of systems that's now all spread around, not only in your own private data center, but it's becoming a modern, true multi-cloud kind of environment. And yeah, so a lot of these customers from us, we did some surveys, and Accenture did some surveys, And these numbers came out of that. So a lot of these companies are struggling to optimize the costs in these cloud environments. Because yeah, you see that, you know, there's the big promise that cloud will bring also cost reduction, but it's quite hard to actually manage this and keep control of what's happening there in those multi-cloud environments. Then 81% is concerned about cloud security. So, you know, now I have all of these workloads that are just spread around everywhere. How can I make sure that all of this is still trusted, and that when these systems talk to each other, they need some credentials or secrets? How can I handle that in a secure way? And then the last 84% is concerned about governance. So now that I have all these distributed environments where people are provisioning things on the fly, how can I make sure that I'm still complying with all these compliances? For example, PCI, GDPR, you know, how can I be compliant with all these rules and regulations now that I'm in all these different environments? And a lot of this comes down to the fact that, you know, if we break this up a little bit, that you can see that there are different workflows in these environments. So for example, you need to provision some stuff, you need to secure your applications or your services. These need to connect to each other, and you also need to control how they run. And when you were on premise, when this was still pretty static, you had dedicated servers, and you had high trust IP-based security, for example. Also the connectivity, you know, if you would know that your database was running on this specific static IP address, and you had dedicated infrastructure where you could just simply SSH in and, you know, control the run of a certain service. But this is now changing, right? You get capacity on demand now. You get servers or container platforms that just spin up and down as capacity is needed. Again, you can no longer rely on IPs, for example, for identity, because these constantly change. If you have a new container, it has a new IP address. So how are you ever going to find out if you need to trust this container, yes or no? So these are all kind of problems that come with this kind of dynamic infrastructure. And a lot of these providers provide solutions for this. The major issue here is that all of them are separate, right? So each of these platforms has their own solution for some of these problems, which is perfectly well in their own environment, but it's mostly an illusion to think that you're ever going to be stuck on one of these platforms. So maybe you are lucky and you can only get 2 of them, but most companies at some point will have, you know, some on-premise resources, maybe some stuff in AWS, some in Azure. And what HashiCorp tries to do is provide a very consistent workflow for each of these different workflows that are out there for these environments. That's the same no matter what you are doing. So even for your own static dedicated infrastructure that's still there as a legacy, that's can be all part of a single workflow that's consistent on all of these platforms. So no matter where you are, the workflow will be the same. If you're talking about security, it will always be the same kind of workflow that you're doing. There's no difference if you're doing security for AWS, for Azure, or for Google Cloud, for example. So one of these products is called Terraform, and Terraform is all about the infrastructure. So, you know, if you move to these cloud environments, you need some infrastructure, right? You need firewalls, you need the service to be provisioned. And what Terraform tries to do is we're trying to provision this infrastructure in a single workflow. As I said before, it's all the same, right? So it doesn't matter if you're provisioning infrastructure on your F5 that's in your own data center, or you're trying to control the security rules in your VPC in Amazon, for example. It's the same workflow. And that workflow can also be opened up as a self-service infrastructure. So maybe you have a portal, or we even integrate with ServiceNow, for example, so that people on demand via portal can provision their own infrastructure as they need it. And in the back, that all relies on Terraform to keep it consistent and keep it in a controlled way. So what we do with Terraform is we have a principle that's called infrastructure as code. So it's a very simple descriptive language that we use that describes your infrastructure. The big benefit of this is that you can put this code in a version control system like GitHub or GitLab, for example, or Bitbucket. And that makes human error way less frequent. And we can also do versioning based on that, right? So it's very easy to roll back, for example, if something went wrong, and we can exactly see what changed over time because of these version control systems. Then we can also put the policy in there. So maybe you have a policy that doesn't allow people to spend a certain amount of money, right? You want to control that they're not spinning up these huge instances in AWS. You can write a policy, again, put it in a version control system. And when somebody tries with their infrastructure as code to deploy these expensive instances, we will make sure that it's blocked or that an additional approval is needed, for example. And then from this infrastructure as code, we deploy that on any of the providers that we have. And there is a very big open source registry of providers. So of course we support all the major cloud platforms, but there's a lot of other plugins, for example, for your F5, for your traditional on-premise infrastructure like VMware. There's more than 250, I think, at the moment, providers out there for different types of infrastructure to provision with Terraform. So that's quite a lot. The second product I want to talk about is Vault, and Vault is all about secret management. So Vault is your single source of secrets for all your different providers where you're running. So it allows you to centrally store and protect these secrets across clouds and across applications, no matter where you are. What we also do is we help applications to build in data encryption. So we can provide you with certificates, for example, so that applications can now talk over encrypted channels with each other. We also have stuff for advanced data protection. So we provide also encryption as a service. So maybe you have sensitive data that you want to store in a database. You can use Vault to encrypt that data and then store it in your own database. Vault can take care of all the key rotation, all the necessary steps to make sure that this is a secure process and that whenever there's something compromised, that you can still keep it secure. So you don't have to care about implementing this security principles and verifying that it's implemented correct. You can just use Vault as a service. So the idea behind Vault is that you have an application or a user or something with an identity that authenticates itself to Vault. And then Vault will apply a policy to this user or to this application. And that policy controls whatever that user or that application is able to do. So your application can be provisioned in a secure way with a single identity. And that identity allows the application on demand to log into Vault, get dynamic credentials for databases, for other systems it needs to talk with, maybe external APIs, maybe it needs to get keys from there. So that single identity, we can provision it in a secure way that it can authenticate to Vault, and Vault ensures that you get a controlled way of access to all these different secrets. Third product I want to talk about is Consul. So Consul provides a foundation for the network workflow in this multi-cloud environment. So the problem with the network is that now you have all these different services spread around all these different environments, and they have these dynamic IP addresses. So how are they going to find each other? So what Consul allows you to do, it allows you to act as a service discovery engine. So each service registers itself with Consul. Consul does health checking, so it makes sure that the service is up, online, and healthy. And then when another service needs to talk to that service, it can request Consul, and Consul will tell it where it is. So it's your single source of truth. It's your source of registry of where all these services reside, basically, no matter where they are, if they are in Google or in Amazon. And it also allows you to build up a secure mesh network between these services. So if there's a service A that's residing in Google Cloud that needs to talk to service B in Amazon, Consul will not only be able to for these services to find each other, but it will also set up a secure channel between these services automatically, so that nobody can listen in on the data, even though it's going over the public internet. So again, this shared registry allows network operations to be decoupled from static IP addresses that were used in the past. And now security and finding other services is based on logical services. So what also is very important with Consul, we also have principles built in to either allow or block communication between services. But again, this is not based on IP addresses, this is based on these service names. So you could say, you could have a rule where you say, you know, the web service is allowed to talk to the database service, but the web service is not allowed to talk to the payment processing service directly. So these intents allow you to configure something like firewall rules, but no longer is it about specific ports or IP addresses, because they are so dynamic in these new environments. And then last but not least, we have Nomad. And Nomad provides the foundation for, you know, running the applications in these different environments. We provide orchestration for containers. You know, it allows you to very easily deploy and manage containers at scale. It's a very lightweight platform. It's just a single binary. If you compare it to some of our, some of the other options that are out there, I think Nomad is quite lightweight. And the other nice aspect is that it also allows you to run non-containerized applications. So it doesn't really matter what it is, right? It can be a jar file that's just running on a server, or it can even be a Windows server with a .NET application on there or something C#. It doesn't matter. We can orchestrate it, right? It doesn't matter if it's a single executable or if it's a container. Nomad is able to do all kinds of orchestrations and you know, spreading out these workflows, keeping them healthy, no matter what you're talking about. So to give you a few examples of what we did for some of our customers. This was a very big telco provider, and for them it took about 22 weeks, more than 22 weeks, to get a new application up and running. And basically by using our technologies, actually they used all of our technologies, they brought that down to 5 minutes, right? So that's a huge improvement. And it's just because of a lot of the processes that now got automated, right? There's no more manual steps in there. So it becomes much more agile, and they brought these times down a lot. Then there's this company called Cruise. It's a part of GM. They built these autonomous vehicles, and they create hundreds and thousands of configurations and update them every week with Terraform. So thousands of different kinds of little pieces of infrastructure that they update every week, and they can completely rely on that because they have the exact blueprint of what that infrastructure should look like. And they are sure that every time they do a little update, that you can always go back, and it's always up to what they need it to be because of the policies. Then we have Adobe, which is using Vault at a very large scale. So they do 800 million secure transactions per month using Vault, right? That's a lot. 800 million transactions that are secured by using Vault. Then Consul, Mercedes-Benz, their R&D center, is a heavy user of Consul. They have more than 200 services deployed on multiple Kubernetes clusters, and all those clusters can talk to each other using Consul. So they're using the service discovery, but also the service mesh feature to let these, you know, disjoint Kubernetes clusters talk to each other and be able to find these different services. And then maybe, you know, Roblox from your kids, you know, it's pretty popular with the kids these days. And yeah, they by using Nomad, it's now under 8 minutes for them to deploy a new application on the Roblox platform. They have a lot of these applications. They have more than 100 million players per month. So again, what we're trying to do is provide this consistent workflow for all these different aspects that you now run into when you're running into this multi-cloud model. And we are providing you the single workflow for each of these platforms, no matter where you are, no matter what you're doing. So that's it for me. Simon, over to you.
All right. Hello, everyone. The next couple of minutes, I'd like to talk about a real use case. Let me share the screen. So here it is. All right. Okay, first I have a couple of words about me. I'm Simon Nussbaum from Adfinis. I work there as a senior systems engineer. I studied network technologies at the university 15 years ago, and after some years in different companies working in IT security, I've joined Adfinis. Let's have a look at the agenda for the next couple of minutes. First, I'd like to spend a few words on Adfinis, who we are, and then immediately dive into such a project with an exemplary customer, what their problems and needs are or were, what the solution is that we developed in cooperation with the customer, and of course also with HashiCorp. We always also work together with HashiCorp in such projects, and about the challenges we had to overcome, and finally some things about where to start and what such a project will bring you.
Hey Simon, just to interrupt you really quickly, you aren't sharing your screen, so if you just wanted to hit share.
What? Oh, sorry.
No problem.
There is another button. So sorry about that. This is the agenda. I just quickly restarted. First, I'd like to spend a few words about Adfinis, who we are, then immediately dive into that case with an exemplary customer, what their problems and needs are or were, what the solution is that we developed in cooperation with the customer, and of course also HashiCorp, and the challenges we had to overcome, and then at the end some takeaways for your company. So about Adfinis. Adfinis is a service provider in the open source environment and was founded back in 2000. This year we're celebrating our 20th birthday. Over the years we've grown to over 70 employees, most of them highly skilled professionals, and most of the founders are still working at the company. We are still located in Switzerland, so am I. And recently, as you heard before from Koen, we're also in the Netherlands. Our focus lies in strong partnership with open source providers and a broad customer base. Our main partners are Red Hat, SUSE, and of course HashiCorp, where we hold the highest partner standard status. We work very closely with HashiCorp. As I said before, for this presentation, we've taken a real example of a customer where we integrated Vault recently. Let's have a few words about the company. It's a company in the finance insurance sector. As you might imagine, they are heavily regulated, like GDPR or FIPS or whatever standards they have. This will of course bring additional challenges. The company has over 50,000 employees and a little more than 10 million customers. They are spread around the world. They have 2,000 branches and subsidiaries in different countries. And at the headquarters, they have 3 data centers within the same region, and that's also where we started with implementing Vault. Well, the problems they were struggling with, that's quite similar from customer to customer. With that amount of branches and all around the world, you have different solutions that people are using, and the secrets are spread all over the place. So they were really struggling to keep track of their secrets. And another problem that was identified was plain text secrets. From my time in security, it was always easy to have a look at internal source code repositories of, for instance, of the CI/CD chain, have a look at the bash history of some server that you've logged in, or just at scripts that are left by some administrators, and you will most certainly find some secrets that you can use if you're an attacker, of course. Then the monitoring of secrets, they of course have monitoring of the very precious secrets, but with all the cloud service and so on, a real monitoring of everything they didn't have. So they weren't sure when are credentials used or secrets, and where were they used. For instance, are they still valid? Which comes to the next point. When was it rotated the last time? Different types of secrets, they have to be rotated differently. Some they have to be rotated manually because it was simply not possible. And with Vault, you will have the possibility to automate more of this, and you are not too much dependent on what solution you are using. So with Vault, you will really have a standardized way to across platforms where you can rotate or manage your secrets in a automated way through API. And about the scope and the needs they were having, they were looking for Vault to exactly tackle the problems we were talking about before, but they had some additional wishes. They wanted to have, for instance, HSM integration. That's quite common in this sector. Companies usually have hardware security modules in place, and where they keep their most value, the most precious secrets, such as CA, key pairs, or some high secure data container credentials and such things. So because Vault will become your main secrets engine, you probably also want to have an HSM integration. But the biggest advantage to have the HSM integration is that you have auto unsealing. Auto unsealing means if the Vault boots, it gets automatically unsealed. I just have to explain this real quick. If standard Vault installation starts, it comes up, but it stays encrypted. All all secrets that are stored within Vault are encrypted and not accessible. And it's then a manual process to unseal your vault, to decrypt the stuff. And with an HSM integration, you can automate this. So if one vault has to be rebooted or by accident reboots, it will automatically be unsealed and will join the cluster. As a start, we had, as I said before, we had the 3 physical servers in 3 zones. Later on, they wanted to have also a disaster recovery cluster. Disaster recovery cluster is the exact copy of the primary cluster, and in case the primary cluster goes down, you will be able to switch to the DR cluster. One of their additional needs were that they wanted to delegate secrets management to their different teams so that they are able to manage some of their secrets in a company policy compliant way. And of course, they had Active Directory in place, and also the users should be able to log in with Active Directory credentials, and the different teams, they should be also able to sign certificates, to hand out certificates to machines or to servers or to clients. And after this, everything is in place. You can start with storing your secrets in secret stores and access them through app roles. That's the authentication method for machines, that it's strictly API driven. So let's have a look at the solution we developed, but first have a look at the reference architecture. We usually discuss the reference architecture with HashiCorp directly. This is the reference architecture with integrated storage with Vault for 3 zones within the same region. As a start, this is good for the customer. In an ideal way, you would have 1 cluster per zone, but in this case, as a start, this is enough. If you have this setup, you can 1 zone can go away. Also, you can use or you can lose 2 nodes, for instance, the node in zone B or the node in zone C on the right side, one of them, and you still have a quorum of 3 nodes left. So this is the initial setup we had. We had, as I said before, we had 3 physical servers in zone, 1 in zone A, 1 in zone B, 1 in zone C, and below you'll see the HSM integration. So they had a physical HSM node in each zone. They were together, they were attached within a cluster. And in case, for instance, the HSM in zone C goes down or has a problem, the Vault in zone C will switch to an HSM and in the other 2 zones. So then we developed together with the customer and with HashiCorp, we developed how the setup should look like for that customer. On top, you will see the root. This is the main namespace of Vault. If you are installing plain Vault, you will have just the root namespace. If you would like to use namespaces, you you need to have a Vault Enterprise version. So the root is the root is where we started. They were looking for 2 different areas: the development area, the integration area, and the production area. A quite traditional approach. And for each team, they wanted to have such a namespace per area. And as you can see, they had also root CAs for development, integration, and production, and the same for LDAP. And in case you were, when you create a namespace in development, it will automatically create a sub intermediate CA from that is signed from the sub CA from the development. And then the other thing is the user can authenticate against the LDAP in development, and they will automatically assign to a group in the namespace where they have different roles. And with those roles are also policies attached. And in this example, you will have like the developer secrets area. And for instance, the user role is allowed to write down, to write, delete, read, or whatever. Yeah. And the challenges we were facing. The challenges are also, they weren't very different from other customers. The biggest thing usually is the know-how transfer. You probably all know how this works. A consultant comes in, installs something, and is gone after the project. And then probably the guy who was involved in that installation is also gone. And then you are there with a solution, and nobody knows how it works really. Adfinis usually sets up Vault or other HashiCorp products together with the customer. And for this, we provide guides that lead through the installation and configuration, and also provide some guidance for operation tasks, like in this case, how they add the remaining 2 nodes that are missing at the moment. And then we, as fast as possible, we go over to the use cases where we think there is the biggest profit by the customer. We implement the use cases together, and also there they will get some guides and a lot of things they will find on GitHub, also in our repository. And another thing is the structure of secrets. You can really structure the secrets as you like, but this also has a high risk of chaos. So as you can see in that example here, you can have a secret store, that's the KV, that's a key value store for secrets. And this one is for everything. So you have for area 1, area 2, you have the same KV store, but you can also have for each area, as you see on the right side, you can have different key value stores. So this makes it easier if one area is going away or whatever happens to this area, you can just drop the key value store. It's really worth it to have some thoughts about how you want to structure these things. But also the nicest initial structure you develop will probably not be the last one. And then we were thinking about, for this customer, how can he deploy the whole namespace configuration in a managed way, because if you have that amount of employees and teams and branches all over the world, you probably will have a lot of namespaces. So we thought, yeah, let's use Terraform for this. Jonathan did already a quick introduction. So with Terraform, you have infrastructure as code, so you can deploy, configure, and manage your infrastructure as code, and you have always your current deployment status through a state file. For all HashiCorp's products, they have providers that extend the functionality of Terraform to also configure their products. There are other providers, like for instance Google Cloud, Azure, AWS, where you can deploy virtual machines or services in those clouds through Terraform. In the black box, there is an example of such a resource. In this case, it's LDAP authentication, and where you have the different variables set for how you connect to your local LDAP or Active Directory for user authentication. It's just a small example how this works. In this case, on the left side, we developed a small module, a small Terraform module, where we were able to create those namespaces. You have here you have a namespace test1 name. You have a key V store named KeyV. You have a LDAP out method called LDAP. You have the LDAP properties or parameters you need to connect to your DC, and you have a couple of policies that shall be attached to the newly created namespace. Then you plan your deployment. With the plan, you'll see what will be created. In this plan, you have 4 things that are created. That's the namespace, that's the secret store, that's the LDAP auth method, and the policy. So that makes it 4. And if you are sure everything is going to be deployed according to plan, you can hit apply, and the resources will be created. Another thing is, if there are HSMs, the HSM integration is always a thing that can lead to delays in the project. It usually is best if the HSM guys are aboard as soon as possible. So if the words you can read here, if you don't know what they mean, you probably should find the guys who do. And another thing is that, as I said before, you have the HSM is not just there to provide auto unsealing to Vault. From a customer perspective, it's usually there because they keep their most precious secrets there. For instance, private keys for CAs. And unfortunately, or no, not unfortunately, that has a reason, but it's not possible to use the intermediate CA functionality of Vault and keep the private key in the HSM. And probably you have also this policy that you need to have those keys in the HSM. But for this, with the HSM integration, you can make sure that the key and all the secrets are encrypted by the HSM before they are stored in Vault. So you are not able to access the key without connection to the HSM. And this, of course, makes it FIPS compliant, which is usually the original reason why the security guys are asking you to keep the private keys in their HSM. But after you manage this, you have a nice auto unsealing, and you are compliant at a quite high standard. For those who don't know what FIPS means, FIPS is the standard where, for instance, payment terminals for credit cards and so on are certified. And yeah, let's come, and that's my last slide. As you heard now these couple of minutes, with Vault you will have an API-driven and thorough monitored secret management. Really consider using Vault Enterprise for bigger environments, because disaster recovery, cluster performance replication, and also on-premise HSM integration those are enterprise features. If you are just new to Vault, your starting point will be learn HashiCorp.com, where you have a huge amount of e-courses, manuals for all the products of HashiCorp. Another recommendation is, if you start using Vault, start as simple as possible. Get confident with all the things you can use in Vault, and get more advanced later. If you start advanced at the beginning, you will most likely lose the oversight. And yeah, consider looking into Terraform for managing Vault. Actually, you could manage your whole Vault installation with Terraform. Yeah, just have a look at it. And if you need help, just contact us. We'll be there. Yeah, that's it. Thank you very much.
Yeah, thank you, Jonathan and Simon, for your clear story. I don't know if there are any people. We have a question and answer functionality within what's the name again of the Zoom? Sorry, within Zoom. So I will give maybe 30 seconds. I will wait 30 seconds. People can ask questions. You can also use the chat function if you would like to do that. Okay. Well, I don't see any questions. If you got any questions afterwards, please contact someone involved in this.
There is a question. Sorry,
yeah?
there is a question in the chat.
I missed. Yeah, sorry, missed that. Yeah. HashiCorp, is the github.com HashiCorp Vault service broken project still active on your side? I think that is a question for Jonathan. Can you please?
Yep. Yeah. Can you guys hear me? Yeah, sure.
Yeah.
I guess so, right? Let me check that. I'm not sure on top of my head. Should be. Doesn't say that it's that, but I will check that.
Okay. Any more questions? Okay, then I would like to thank everybody again, and I will hope you to see you again. Oh, there's another question. Okay, thanks. PS, we have raised an issue already. Okay, there's already an issue raised, so then I also assume that the question will be answered via this issue. Okay.
Yeah,
Thank you,
absolutely.
everybody. Stay safe, stay healthy, and I hope to see you again in a next webinar. Thank you, everybody.
Thank you, guys. Bye-bye.
Bye-bye.
Thank you.